In this video, we're going to talk about the overbooking ratio method, and this is what we're going to be using to come up with the best overbooking level. And so remember I talked about the newsboy problem? That's a very classic problem in inventory theory of all things. And there's been a lot of math that's been done with this, trying to figure out what's the model that can be used to come up with the right inventory level. So in the case of the newsboy, it's how many newspapers. In the case of the bakery, how many pies. And in our case, it's how many rooms should we overbook by, because we've got these different costs going on. So we've got the cost of an empty room, and that's going to, that's an opportunity cost. We've got the cost of walking, and that's more subjective, but it's going to be the cost of angering people and all the cost of accommodating people and so forth. And then we've got the probability distribution of no-shows. And we've got to balance this cost of empty and cost of walking with our probability distribution so that we can keep our risk to a minimum. We're trying to come up with the lowest cost overbooking policy. And so let me show you this overbooking ratio. It's basically what it is. It's the cost of walking divided by the cost of walking plus an empty room. So we're kind of balancing the risk here. And let's just calculate this. Again, it's cost of walking divided by cost of walking plus empty. And so if we go back to Hotel Vista Bella, they can sell each of their rooms for an average of $250, and the variable cost is $50. So their cost of an empty room, their opportunity cost is $200. If they have to walk a guest, they estimate that it costs them about $500. So we've got cost of empty, $200, cost of walking, $500. So let's calculate that ratio. So it's just going to be the cost of walking, $500, divided by the cost of walking, $500, plus empty, $200. So it's going to be 500 divided by 700, or 0.71. Now you might be wondering, well, what in the world am I going to do with that number? Well, we'll get to that in a moment. The next thing we've got to do is we've got to come up with the cumulative probability distribution. And what this is this is the chance that you have at least a certain number of no-shows. Because what we looked at before, we were looking at things like 10% of the time there was 0 no-shows, 15% of the time there was 1 no-show. The cumulative probability distribution will be having us looking at things like, what's the probability that I have at least 0 no-shows? Well, that's not a trick question. You never have negative no-shows, so the probability that you have greater than or equal to 0 no-shows is 100%. Now, we also want to start looking at these other ones. So what's the chance that we have at least 1 no-show? Well, let's see. 15% of the time we have 1 no-show. But 25% of the time we have 2 no-shows, 30% of the time 3, 15% of the time 4, 5% of the time 5. So I could add those up, and that comes up to be 90%. Or the fast way to do it is I could say, well, 100% of the time I have 0 or more no-shows, minus 10% of the time when I have 0 no-shows. So 100 minus 10, 90. And then 90 minus 15, 75. And let's just take a look at a couple others just to be sure you understand where the numbers are coming from. What's the probability that you have at least 4 no-shows? Well, let's see. 15% of the time there's 4 no-shows. 5% of the time there are 5 no-shows, so 15 plus 5 is 20. And then what's the probability that you have at least 5 no-shows? Well, that's just 5%. And so the easy way to do this is start off at the top at 100%, then 100% minus 10 is 90, 90 minus 15 is 75, and so forth. And one thing to remember is that at the very bottom of this, I'm going to have the 5% of the time I have 5 no-shows, 5% of the time I have 5 or more no-shows. Those two numbers should be the same. If they're not the same, you've made a mistake. Not you probably made a mistake, you made a mistake. But it's pretty easy to do. So now we're ready. I can show you this trick. So remember the overbooking ratio? Well, ours was 500 divided by 200 plus 500, or 0.714. What the trick is, and this comes from the inventory theory model that I was telling you about, is that we look for the first cumulative probability number that's bigger than that. And then the corresponding number of no-shows is how many rooms to overbook by. So let's just try it. And so we go back and we look through the cumulative probabilities, and it looks like the first number that's bigger than 0.714 is 75%, okay? Then we go over the corresponding number of no-shows. Well, that's 2. So this means that our best overbooking policy, our lowest cost overbooking policy, is to overbook by 2 rooms. In the long run, this will be the lowest cost one. It'll be better than any other overbooking policy. So it's a very simple sort of approach. And so to kind of review the steps, you come up with the cumulative probability distribution and you determine the overbooking ratio, or you could change the order of that. It doesn't really matter. And then you use the trick. You find the first cumulative probability value that's larger than the overbooking ratio, and then you go over to the corresponding number of no-shows. That's how much you should overbook by. This gives you the best overbooking level. And some things to think about. I mean, the cost of walking are subjective. You might have a different opinion of it than somebody else, but the nice thing with the model is that it's easy enough to change the number. It doesn't consider multiple night stays, and it doesn't consider the number of arrivals, but still, this is the most commonly used method in the hotel industry, and it works very, very well. And it will lead to the most profitable overbooking policy. But remember, you're not always going to be perfect. This is a game of chance. Sometimes you're going to be right, and the overbooking ratio method will give you the best chance of being right. It'll give you the lowest cost approach. A good rule of thumb that some hotel companies use, if they say that the cost of walking is 2 times larger than the cost of an empty room. But remember, this is going to vary depending on where you are. But the overbooking ratio method, again, very popular and successful method that many hotels use for their overbooking policies.